All right, now after talking about magnetic flux, and we can use that idea to discuss how a moving magnet can create or generates current. So all the ideas about this interaction, like how the moving magnet with the current, and that's all included in these two laws. One is called Faraday's law, and another one is called Lenz's law. Basically, Lenz's law will tell you the direction of the direction of the current it induced, while the Faraday's law will tell you the magnitude. So let me give you, but don't be scared away by this fancy names. The idea is actually quite interesting. So now let's look back at this question. If I have a ring and this is a conducting loop, it could be a wire, a ring, whatever, as long as it's conducting. So we can put a ring here. And now you can see this ring had no charge to start with. It had no current to start with. It's just a very normal ring. There's no current. It's just like stand alone there. And now if I put a magnet next to it, then nothing would happen. They just happily stand where they are. However, what if we move the magnet away from the ring? Say I'm moving it to the right. Then what's gonna happen? So to answer this question, let's take a snapshot, like one at this moment, and then one like say 1 second later. So if we take a screenshot, this is what you will see. Okay. So if we take a screenshot before we move the magnet, then you can see that this is my ring, and on my ring you can see there are 5 magnetic field lines going through. You get 1, 2, 3, 4, 5. Okay, so the magnetic flux in this case, before it will be 5. Okay, the magnetic flux is 5 to the left. Okay, and now what if we move the magnet away? After we move the magnet away, you can imagine there will be it will be fewer magnetic field line going through the loop. So it will look more like this. So instead of 5, you will have only 3 now, let's say. Okay. So this is just a number I made up. It's probably 2 or 1, I don't know, but I'm just making it up. Like there must be a moment where there's only 3 magnetic field line going through the loop. Okay. So think about this. If you were the ring and originally you have 5 to the left, and now you only have 3 to the left, then how do you feel? If you were this ring, then you will feel unhappy about it. You don't want any change in magnetic flux. So this is the key step. This is a key idea behind all of this. The loop does not like the change in magnetic flux. So if the ring feel like it's losing the flux, then this ring will be unhappy and try to keep its life the same as usual. So the ring will try to create 2 more magnetic flux to the left by inducing some extra magnetic field. So you can see that these two red arrows suggesting the induced magnetic field by the loop. But how can a loop just arbitrarily create a magnetic field? It cannot unless it has some current running on it. So to induce this extra 2 magnetic field line to the left, this ring will induce a current running on it. And this current, so now this is a time where you want to use your right hand rule too. So to induce a current to the left, so to induce a current to the left, I must have a current running in this direction. So if I draw it out, you can see I must have a current running in this direction to induce the magnetic field to the left. All right. So now so this is what you will see in real life. Well, as you move a magnet away from a ring, this ring will have a current running on it. So this is what we usually say, that moving magnet will induce current. But if we think about it more deeply, the whole idea about why moving magnet can induce a current, this whole idea lies in the heart that any rings, all the rings, they don't like to be changed. They don't like the change in magnetic flux. If the magnetic flux is reducing or increasing, then the ring will be unhappy and will try to compensate the change and make its life go back to usual. So what I'm saying, so this whole idea is we call Lenz's law. And if we write down this idea in math, then that's Faraday's law. So which goes like this. So let me show you how to read this math. Okay, so if there is any change in magnetic flux, then the ring will want to oppose, so there's a negative sign, the ring want to oppose the change. And to oppose that change, it must create a current. But how can the ring create a current? This ring must have some electromotive force. Electric motive force is nothing but the voltage. So Faraday's law is saying, if I have a change in magnetic flux, and that will induce a voltage, it will induce a potential difference. And because V equals to IR, if there's a potential difference, then it will drive the current over this resistor. So the current induced would be whatever V you get here, and divided by R. And if you have a more loop, if you have a more loop and all the loop, they will create a voltage across them and they're all in series. If you add them up, there's a vector of N here, the number of the turns of wires. All right. So basically that's it. This is Faraday's law.